Hey, apparently we're live on YouTube. Hey everybody, welcome to another episode of the Operation Grow Show. This is going to be episode panic, quick, shit. Fuck, I do this every time. I clean forget which one it is. All right, hang on, I'll wait for it to load. It'll tell me. There we go, 19.
I thought about tracking it for you,
Um,
but it really is more fun listening to you panic at the beginning of every episode about what episode it is. I kind of gotten used to that.
and the
As
crazy thing
is
is,
tradition.
I just typed it in a couple of minutes ago, you know. That's the worst bit. Yeah, so thanks. Yeah, great. Yeah. And on that note, GMF, hey, how you doing, buddy? How you doing? How things going?
Excellent. I can't complain. I'm lucky enough to be here hanging out with y'all, just getting some macro shots today of the tent, just so I can see where I'm sitting, kind of sit and assess kind of day. So yeah, I can't complain, man. I'm a lucky guy to be above ground and hanging out with y'all and all these wonderful people in chat.
Oh no, I just seen in the chat that the reason why Tyler will not be joining us today is because his missus broke her ankle this morning. My apologies, Tyler. Well, that doesn't sound great.
Best of luck to
That's
your missus,
because you
Tyler.
put enough. The thing is, you made the chain in the kitchen a little too long, so they got enough time to build up enough momentum. So when the slack suddenly snapped, if you keep it shorter, they can't get up to speed, buddy. uh, oh dear, oh dear. Well, yes, moving on swiftly. Lefty, how you doing, sir?
I'm doing all right, man. Happy to be able to be back on the show this week. Still busy, but yeah, I had to take a break to get caught up on things. But yeah, things are going good, man. Got a lot going on right now.
I hope you got some pictures of your greenhouse too. Although that's the last thing on your mind right now, but I'm sure it would be nice to see some pictures or at least hear more about it. What's happening in that space? I see you just had a little bit of soil delivered the other day.
Yeah.
A wheelbarrow or two, I'd say. Yeah.
Yeah, I had 12 yards of bagged, essentially potting soil come, and yeah, I got 4 yards of that. I got one of the three beds finished out yesterday.
Mhm.
So yeah, just doing a little insect screening today. Just trying to get the cover fastened down a little bit on one side, and yeah, I got to get the rest of the soil in there. But yeah, it's been hurry up and wait, and now it's hurry up kind of deal. So yeah, trying to get that done, trying to get things ready, germinated for the season inside and outside, and veggies, and 9 to 5 work job thing, and all that good stuff.
Fantastic, man. Fantastic. And Cascadian, buddy, how you doing? How things going?
Doing good, man. We had a couple days of bad weather. The sun came out today, so I'll be here, but I won't be here for much of the after show today. But I'm glad to be here. It's nice to see you guys again. I think we got something in store today.
Yeah. And Raptor, buddy, before I last but not least, nice new background there. I see a space tripping Raptor by the looks of it.
Yeah. I need to actually resize it and get some friends on a digital print of it, so I can set up multiple things. This background is brought to you by, he is in chat, I Gruesome. So thank you so much, I Gruesome. You did great work. I paid for this, and I was happy to pay for it. I really like all the work he does with other people as well. Again, I wish I resized it properly to fit into Zoom a little better. But yeah, you could see a raptor foraging and feasting in a field of mushrooms. So I think he got it.
Yeah,
And yeah.
Similar.
Yeah, there you go. It's a match.
Style.
Yeah.
I don't know. I mean, not from the same. Well, if it is from the same artist, my apologies. I found this one online. Oh well, digital.
Yeah. I really like him. I just took what he sent me, his scan, and then just kind of edited it a little bit, but it still needs to be done a little better. That being said, yeah, I have a couple friends that I've been wanting to do backgrounds with, and also just designs for my mushroom cultivation business. So yeah, should be interesting for those sets. I have kind of going away from the Raptor and just like making it something different. But yeah, other than that, yeah, again, thank you so much, I grew some. I'm really enjoying it. I'm gonna have it around some more, and especially digging it as a background, as an original background. But yeah, in terms of news, yeah, the grow season's picking up outdoors, just prepping everything. I'm like a month behind where I could have been, but the season is so long here that it's kind of forgiven. I will be doing much less. I'm gonna stick to melons and some herbs and just simple stuff. I don't want to, on my first year of really gardening on the annuals, overdo it. Just like, hey, maybe some peppers, some tomatoes.
Yeah, I've got so many
Yeah,
chilies at the moment.
yeah.
Again, I was back in
I've
the
been known to
greenhouse
overdo it.
looking at all of those, going, I got to figure out where I'm going to put all these damn things. Realizing, oh yeah, no, they do get quite big. Yeah, I know they're only this big now, but you clean forget in a few weeks' time they're going to be these beasts, and like, oh, and then it's all the IPM and all of that in the greenhouse, and dealing with all that shit, and still being able to reach and things. There's going to be some heavy. Pruning and training of chilies, because otherwise there's also just way too much of it. So I don't mind being a bit brutal and just clipping things off just to keep them in check if I have to, because otherwise, yeah, there's
Hey,
just
that's
way
part
too
of
many
it.
fruit.
Even in
26 chili
breeding,
plants is going to be like
look at breeding, for
chilies for
example. You
decades.
got to call.
Mm-hmm.
They all might look good, but it's part of it. You got to
And
make
if you end
room
up with
for everything else.
Yeah, and if you end up with too much, let me know. We'll make you some fermented chili paste, and you'll be done.
Oh yeah.
Exactly.
Oh no,
That's
no, I gotta we'll make
my
ourselves all
route
sorts
for
of
peppers. I got plenty of family
wonderful hot
members that are
peppers.
waiting for
I planted so
peps.
many veggies this year. I had to make a map. It's bad.
Yeah,
Mm.
I'm trying not to do that first round. I've done that with other stuff that I've gotten for perennials, just because I was like, oh, it's going to be around. Like, I want them early on in the stage. Good thought, but be prepared. Don't overdo it, and then you're stuck with dead perennials. So I have kept the majority of what I had, but did have die off last year. So I took that mistake and took it to heart. Like, hey, don't overdo it. I have a lot of seeds to grow. Doesn't mean I have to grow them all. But yeah, gonna be working on the Black Diamond variety of watermelon, actually, that I got from Cascading. So looking forward to that. Looking forward to some melons as well, some cantaloupe. Yeah, just basic stuff. But yeah, that's about it for me. Yeah, really. Oh, I did actually plant, speaking of perennials, Chabota like 47, 48 little trees, but just in seedling form, like from seed. So they're doing well so far. There are two varieties. One is a precocious variety, so early flowering.
Mm-hmm.
And then the other one is I'm going to have to wait till like 5-7 years to see them flowering and fruiting, but it's a tree. And I'm fine with that. That's what I wanted to get into. This is just going to be the beginning. I've been wanting more. I didn't want to have too much. Again, a little too much. That might sound like enough for other people. Yeah, nice. Yeah, I definitely need to make a map of mine. And graph paper is perfect for making maps as well. So yeah, maps, lists, love it overall. But yeah, forward for those to be showing flowering so I can mess around with breeding. The early flowering ones, I should be getting some fruit in 2 to 3 years. So yeah, that's about it for me.
Cool.
I know that you got some, you've been twiddling your fingers, just waiting to let everyone see what
Yeah.
you've been up to.
Oh, excuse me, taking a big slug there. Yeah, no, what I was thinking about is that, we've we've been talking about all of this now, talking about all the genetic side of things and whatnot, and how you know traits pass on and breeding programs and how it's all about the numbers, and the more numbers you have, the better it is. And we've talked about like bottlenecking that can occur, you know, either through selection process or through natural events that take place. You could have, you know, die-off events that just remove huge chunks out of the equation. And you know, when it comes to actually doing it in practice, part of the catch there, of course, is like, yeah, how do you make 50,000? How do you do 100,000? How do you do 300-400 generations of this? You know, how long does it take? And some people have asked the question, like, you know, how long do you have to go before it becomes homozygous, or it's stable, or becomes its own thing? Which is a really difficult question to answer. So I thought, well, okay, hang on. Maybe they could write some software to do this, which start off like, what the fuck? How difficult can it be? And like, well, okay, hold it a second. And then you go through this bit like, it's really difficult, like 10,000 lines, back down to hardly anything, back up to all of this, back down to hardly anything. But yeah, eventually, so I've managed to write a little software that basically simulates population genetics. So you have little blocks, and these blocks can either be male or they can be female. If it's a female block, it doesn't move to represent a female plant being stationary. If it's a male block, it's tiny. It's half the size of the female block, and it'll buzz around like it's pollen randomly moving all over the place. When a little block, I'm explaining the rules so when you see it running, it makes a little bit more sense. But then when the little blocks bump into the big block, so pollen hits female, they split their DNA, their genome, and swap that randomly between each other and create a new genome as a result of that, that has a new phenotypic expression. And you've defined the phenotypes for the genotypes, and then it keeps a track of those, and then you watch this population go. Now, there are certain stress events, like if a female has been alive for more than a certain period of time, it will it will self, but it will only produce more females. It won't produce any males. There's also some stress scenarios that says, like, if the male population dips below a certain number, and there are still males alive when it dips below that number, then those males will produce essentially flowers and populate, but because they're males, they will produce both males and females at that point. Again, but by randomly mixing, you know, splitting and going through that normal process. That's how they're doing it. But they can all just die off like that. Each plant is assigned a random length of time that it will live for, and that includes the male pollen, how long that will be alive for, that has a random time associated to it, etc., etc. For sake of completeness, if I haven't lost anybody yet, here we go. This is down the rabbit hole. But okay, so we have two parents. Let's keep it simple to start with. Let's do the most, you know, the usual example of, let's say, homozygous recessive and homozygous dominant. What's this clip? Yeah, there we go. All right, so we've only got homozygous, you know, for P1 and P2, those are our two parents. Those we're going to use our starting material, and the phenotypes are that if it's A, it's tall. So if a capital A appears in any position in this genotype, it will assign it the phenotype of tall. Capital B appears anywhere in there, it'll be assigned the phenotype of broadleaf. Only if it's a double A will it be short, and double low B will it be narrowleaf. That pretty simple rule that we're used to. And to show that the females, the little squares on the screen will actually show their phenotypic expression. So we'll say if it's double A, it'll make it 1.5 times taller. And she said it, let's go. We'll make it twice as big. Otherwise, make it half if it's short. Anything in between, it's the normal. So you'll be able to see the ones that are expressing these dominant genes and the recessive genes. And we'll start with the maximum population of 1,000. And our initial population will be 500. So we're going to take dip our hand in a bag of seeds, 500, throw them out. Well, we're going to tell these two plants to breed. The initial parents, they produce 500 seeds. We throw the 500 seeds out in a field and we just let it go. This is what this simulates. It's just open pollination. It's just free for all. If any of the lines manage to go long enough, if they manage to go continuous genetic line runs for 500 generations, it will mutate. And all the mutation is it just randomly picks one of the genes, the genotypes in the gene, or one of the genes in the genotype, and it just reverses the alleles. So if they're double A, uppercase, it both become lowercase. If it's uppercase, lowercase, it just switches them. So you just get this random mutation on just that will take place. But it's only if they make it that long, because you would say, okay, at that point there's potential that errors might creep in. So that's what we've tried to I've tried to simulate at that point. Right, and on that note, sure. Any questions from the panel? I mean, I know from the crowd it might get a bit, but here we go. I tell you what, let me fire it up. So we're going to start with that initial fairly easy one, and of course all of the initial and let me just quickly see how fast is this running to give an idea. It's running through 25 life cycles a second. As well, 25 cycles, so it's considering each frame per second is one life cycle in terms of tick over time. So if you're alive for 500 frames, if that genetic line runs for more than 500, FPS is okay. Anyway, don't worry about it. That's how it's calculating it. So there's the two parents. We've got 264 males and 236 females out there. This will update the second it starts running, and off we go. So we're down to only 3 females all of a sudden. It'll start to. It's interesting to see how the population, it needs, even though you've done this, things need to find their balance, and then they all start to. And all the movement is kind of random.
Like the explosion there.
All random. And they have a limit. Let's see, how long will the males live for? Oh, there we go. We eventually locked into just being a single homozygous genotype. And that took 84 generations through the random selection process for that one to eventually get wheedled out. Now, the things that made this one thing stand out is that it had broader leaves, it was taller, making the actual physical item on the screen a little bit bigger, a little bit broader, giving it more chance of being hit by pollen, for example. But I mean, that's just one example of that at a fairly simple level. Yeah, we can crank it up.
That's cool how you got the size of the plant to translate to the size of the dot too. That's pretty new since I've seen it last.
And in that run, it looks like your final numbers ended up actually fairly similar to your beginning numbers. Your total population of 500 split between male and female. At the end of that run, your numbers actually ended up fairly similar.
Yeah, actually, that's a bit. I stopped. Yeah, so like the total number of males that went through to, and okay, so that was the longest continuous generation that appeared in that line was 84 generations. Not that it took, eventually it got there, but it took 14,628 males and 14,407 females being crossed to eventually get there. So that would in the wild have now produced, this has become its own, this is what you would call its own line. This is a stable line. It's removed everything. Every time this thing breeds, I mean, the simulation stops the second that one phenotype has been locked in, or one genotype has been locked in. It then stops at that point. The thing is, if it had made it to over 500, it would have suddenly tripped it up, and that would have reset some of the generational stuff, and it would have been able to carry on again because it suddenly had a mutation. And that's what happens in the wild. So if we up it to, let's see how we got 3 extra genes. Sorry, I'm not looking at chat. I don't know if people find it interesting. But once again, so we've introduced an extra gene in here. It's either citrus or earthy. So uppercase C, it's dominant citrus. Lowercase, it will be earthy. You can see out of crossing those two parents, it's actually only produced 2 phenotypes initially, whereas last time it actually produced initially only 1 phenotype. And yeah, we'll see how it goes. So already you can see genotypes is 20, 4, 30. It's interesting to watch how many genotypes suddenly appear, will then disappear. Again, making it easy to see when the dominant traits suddenly kick in. And it sort of shows how it would go in nature.
I wonder if the program will automatically skew towards the broadleaf plants because the dots get bigger.
Well, it means they'll likely get hit more often. Yes.
Right.
I mean, that's what I tried to represent. So yeah, I mean, if I can remove then, I can remove it actually showing the physical, like physically showing you the phenotypic expression. I could make all the dots exactly the same size. But I thought what's a bit more interesting is to start to throw in, well, okay, hang on a second. If it is broader leafed or it is taller, maybe that is the advantage. I mean, what is the... well, the other thing that becomes interesting is if you make, although it might make it broader, I can make the narrow, short ones live twice as long. And that could be a different side effect. And that then produces...
Is there a way to add environment? So like, because like in a more tropical environment, it's going to select more for narrow leaf. In a more arid environment, it's going to select more for broadleaf.
Well, what I want to be able to do is take something like, take the screen that it's playing on, yeah, and chop it up and assign zones to this zone, that zone, and then go, if you're in this zone and you have this genotype, then your life expectancy is twice as long, for example. But if you have this other genotype, it's half. And you would suddenly get, okay, so in this area, this genotype succeeds really well. It kind of works there, and watch to see how it naturally separates. The other bit that I thought would be really interesting is hook this into something like the Minder, where you will say like this genotype in this temperature range or whatever it does particularly well. You could actually have it then react to a real-time environment. You could use this to monitor your grow room, depending on what genotypes were there, how they were moving around. It could give you an idea of what was going on. Oh, this is going to run forever. You see, some of these just go and go and go, and they'll never... I mean, up to 132,000. But there's only 4 genotypes, but they've locked themselves in pretty well into... Oh, did we drop Tony's? As I said, yeah, this could go forever. But you can do things like adding like death genes, like so you can do this bit where you could be a carrier. It has no effect, and only if you get it both recessives in, it just kills it on the spot. So it doesn't express any other kind of trait other than it won't succeed. Or you could make it sterile. You could almost simulate anything you wanted.
I just wonder if how it sits, if like if you ran the simulation 100 times, is all 100 going to come out tall broadleaf just from the way that the code is right now?
I've done that. I ran like 8 at the same time. They all came out different, and the dominant one doesn't always survive.
Yeah. So it's just dumb luck that both of those were tall and broadleaf.
Yeah, and the size of starting population makes a huge difference in in what you're gonna, and in the chance of it succeeding. If the population is too small, the initial like in the wild, if the initial population is too small, there's every risk that it dies out, that it can't. Whether it's male or female is random. It could produce all females. You're screwed. Population comes to an end.
Can you alter it real fast so we can look at like a 10 pack? Like if you popped like a 10 pack and say you got like 6 and
In the
4 or 5
wild.
and 5.
And left it to open population. Yeah. Maybe we make it a little bit bigger than a 10 pack. Let's say you pop 100 seeds.
There you go.
For argument's sake. In the same size field. Let's make the genotype a little bit more interesting. Let's say we make them both homozygous for the same traits. So this could be like an Whoops. Boom. All right, so with just 100 plants, same rules apply. Where it'll still get bigger and smaller. That's still gonna apply here. Let me just share that. Well, these could all die off almost instantaneously. There we go. You're watching genotypes of it. So the only thing that's really keeping this population going is the fact that the stress on the male plants occasionally causes them to flower, which is what you're seeing here happening here. But there's been no. Oh, there we go. There's one homozygote. It's tall. There's a lot more shorts than, yep. And that's the recessive one. Okay, so now they're all short. Tall has been removed from the equation, and tall will never appear unless it went long enough to mutate. And in this case, it's hit a stable homozygous genotype, which is short broadleaf citrus, is what it finally, and it started off as tall broadleaf citrus, and left alone in the wild after 237 males and 222 females randomly crossing with each other, and pollen and things allowed to go through, live, died, etc., under these conditions. That was the outcome. But if I rerun it, it's guaranteed not to be the same again.
Right, but that
took guaranteed, but
that took 15 generations, which is a reasonable amount of time.
Yeah, that's to get to, so this was the final genome that eventually got locked in. And so to be able to do that, so that now every time I cross this, sometimes it can end really quick. I mean, you might get lucky early on. I would like to introduce the ability to have it run a little bit and then say, all right, now just pick from the phenotypes on the left-hand side, because you don't know, because actually the color coding of the phenotypes on the left doesn't match what's on the right. That's genotypic color coding. This is phenotypic color coding. They're not the same. Because big A, little a is not the same as little a, big A, but the phenotype is the same. So it'll be like, pick from here the two that you want to go with, and it'll just randomly select any one of those, a male and a female. It'll just select anything that matches that phenotype, but pull that across, and then let that run and see where it gets you to. So yeah, I mean, I can, for instance. So that was with 100. And there were 3. Yes, again, if you up that to 1,000 all of a sudden. Can't remember how many phenotypes we started off when we just, when we started with 100 seeds. It was only a small handful of phenotypes that we started off when we started with that 100 seeds. I think straight away, now that we've upped it to 1,000 seeds, we already have an initial kickoff of way more phenotypes than we started off, which tells us we've got more genotypes that we're playing with. There we go. You can lose hours in this. Some of these just go and go and go.
We literally have.
All right, so now you're seeing the tall rate in this run. Tall's really doing well. In fact, I think tall's probably taken over completely. Yeah. But we still got 4 genotypes kicking around. Yeah, I don't know how. But yeah, so the idea behind this allows you, again, this is a way of trying to be able to visualize what's actually happening if you were to leave it to go. And this is why we say it's this thing about playing the numbers game. Because as you can see, when the numbers really ramp up, a degree of stability kicks in. But if you're looking at the two different, in the ratio of the phenotypes being expressed, it's staying fairly constant, around about 500 of the, what's that, 10 to 1 ratio, roughly. Jumps around a bit, but was it 4 to 1? Yeah, 4 to 1 ratio is kind of what it's showing there. But you're only getting that because you've got 500 plants at a minimum at a time running, and it's had time to balance that out. They do swing. So yeah, I mean, well, that's that bit there. I know. Who's in chat now? Raz in
There's
chat. I need
been
to give him
multiple questions in chat.
send him a
Like
copy
the
of the
most
software.
recent is Magma. How many offspring per plant cross in next gen? And then Jeff was saying it depends on the wind, Magma. But yeah. How do you express that? Do you just put a random
Yeah,
assigning?
so I've told it that if the number of plants is greater than the maximum population count that I've okay, so like any simulation, there's rules to this game. So this is the environmental rules that were set up. You tell it what the maximum population is, so it can't get. Ideally, it tries not to grow above the maximum population. It can, but it tries not to. If it does, then it'll only any pollination will only produce one offspring, and it'll be randomly male or female. But above 1,000, the population tries to naturally curb itself in. Below 1,000, it is populate. Those are some of those population events. So if it's still above 75% of the overall population, it'll produce 2. So it tries to keep it in that band. If population dips lower, it'll produce 3. If it dips even lower, it'll produce 4. So it kind of tries to go into this panic mode to keep the population going, as it would do under normal pressure in nature. As it gets stressed, it tries to reproduce. It really tries to crank itself up. The same applies to, and the females, if a female has reached the point where it will hermy or self create, more females, again, it will do that, and how many it will produce will depend on what the overall population size as well is. If the population size is really big and it gets to that stage, it'll just die off. It won't bother doing it. It doesn't need, there's no. It's tried to have something put in there at certain pressures on the environment that will cause these things to happen. Yeah, so you can. I mean, I could adjust how many offspring it produces. I'm thinking of the one where, and then what happens is, as soon as that happens, both the male and the female die, so they're removed out of the population. So as soon as they bump into each other and pollinate, that's both parents are removed from the equation. The other one I want to try and run is maybe where the mom will stay around and allow itself to be pollinated, multiple times, but only produce one offspring from each pollination. And again, randomly male, female, male, female. And say, okay, when it gets to a certain number, then it'll, after it's been pollinated 5 times, it dies, for example.
Cool.
So in that context, go ahead. I was just gonna say, so in that context, it's still limited to something that our brain can handle, but is not as complex as nature actually is. Because you're gonna have added complexity in nature, but our brains can only do so much.
Yeah. So this is probably maybe a little bit behind on some of the questions that are coming through, but then again, from Magma there, I mean, at the moment, it can't, but yes, I can code it so that it can. So that yes, I can put this thing in to tell it that a mom can be pollinated multiple times, but only do one pollen grain, one offspring, and it does one single switch of exchange of DNA. Right now, it's kind of doing two, assuming that or whatever. So it's assuming it got multiple flowers pollinated by the same male. Is essentially what it's simulating right now.
Can you do it for the other side too? Can you make a one male make 5 pollen grains?
Well, it's more that the pollen is just like randomly created. Those are the males. It is just considered the male genetics. So you could, maybe say that as a result that,
Right.
yeah, there isn't a male plant giving out pollen. It's just as though if this was the pollen that was drifting around and it's just new pollen that gets created. Yeah. But I could produce like X number of extra males each time as well.
Got an earlier question. Well, they have to do with each other. The first one, can't remember the person, but they only made this one comment. Is this open source? And then we had another person asking, Dozer asked, did you use Python? So before I forgot both of those technical questions.
Answer to the first one, it's not open source yet. Second one is yes, it was written in Python and Pygame. So yeah, it will hopefully go into the open source realm, or maybe I'll put it up behind. Actually, yeah, I'm using Pygame and other libraries. It has to go open source. I can't charge for it. But if you want to ask me a question about it, I can do that. I just can't charge for the actual. I can charge for support, not for the software. But yeah. And I see there was a question in there, something about can you input back crossing offspring? I could. Well, what could happen there is we could, if the mom stayed around. So if the mom didn't die as soon as it got pollinated, the mom could stay around if there's every chance that maybe it gets pollinated by some of the male pollen that it created. In terms of the male, I say the male pollen it created, the male that it created pollinates it again. That would be an in the wild random back crossing. Yeah. That it's just that the fact right now is it dies straight away, so you never get the original still kicking around. And the two real original parents that we used, this is more like they were used and you were given this bag of seed, and this is what you're now throwing out into the wild.
All right, so tomorrow I got to chop down a plant.
You're gonna have a bag of seed, are you?
Think so. Yep, I think you're right, Pete. I think you've just made it all too abundantly clear that seeds are going to rain from heaven.
Yeah. Great fun. Yeah. There you go. Oh yeah, Lefty.
Speaking of
there's happened to be a rise cross whatever. Insert next strain here.
Yeah, a rise cross to everything.
Well, sorry, it should be other strain.
Everything in the room.
Cross a rise.
It's going to be a rise by tomatoes, a rise by potato, a rise by.
Yep. This is actually the banana OG here, so this is what's supposed to be pollinated too. But no, everything's got a rise in it. I got F2s. I got Penmarid by Bubba Kush. I got Chem 91. I got all kinds of shit by a rise.
Later in the season, Lefty's going to be, why does this cabbage taste like a rise? It's weird.
It all got it.
Yeah, I want to create a little UI in that for it, so that it's a little bit, because I mean, right now you can. I'll put it up there, but the catch right now is that it's all. You got to make all the configuration changes in the background. And the other bit, I said, being able to maybe have it somehow link into a real-time environment. So if you've actually got something that's logging data, or be able to take your thing and play it through and have it react to a real environment, that could be quite cool. It almost makes it like a living game. or a way where you could sit here and tweak certain little things as a game to share between people. You could tweak certain things to create yours, and if they mutate to a certain point or last long enough to create certain mutations, they can transport over to, I mean, technically it's not difficult to do over the network and that, but so you're running it, I'm running it, I create ones that'll suddenly get the ability to travel. In your game or your version of it running, you suddenly get cross-pollinated from something I've produced, and it now appears blump into your gene pool, and you'll just get this random thing again. My brain's been running overtime on this. It's ridiculous. If anybody out there in chat would like to get involved and get into it, fantastic. I'm more than happy to work on this with someone else.
And where should they contact you if they had any questions, inquiries, or wanted to?
They can drop them in the
contribute
comments
some way?
here if they want to get hold of me. Like, drop in a comment here that you want to get hold of me. Otherwise, you can also catch me at Operation Grow 2019 on Instagram, or PL Grow Systems at PL Grow Systems. You can get around the lisp on Instagram as well, or you can email me directly, peter@plgrow.systems. No .com, .co.uk, nothing like that. Just plgrow.systems, which is also the website, oddly enough, and there's a contact form there. But so many ways. But yeah, hopefully this gives a way of being able to visualize what we're talking about at times, and this we'll put it out there, make it fun so everybody can have a play around with it. I'd like to actually try and get this into a web page. It's one of those things that actually is quite doable. With something like React or whatever, it would be quite doable to turn this into a web page, but and then people can just go up there and play it. And the cool thing is that means it all runs on their computers, not on the servers. Fantastic. So yeah, that's that bit done and dusted. I'm good on that. Lefty, what are you up to, buddy? You got a nice big greenhouse going.
So yeah, getting my soil in is where I'm at right now. So I've got 3 beds, 54 feet long, 5 feet wide, and I brought in Bio 365 all their organic potting soil mix, and then I'm amending that with a very coarse sand and compost. So I'm just building a good base. It's gonna stay in there. It ain't gonna ever coming out. So I'm just building up a good base that I can amend every spring and fall or accordingly. But yeah, it's been quite the undertaking. When you get ready to do stuff, it's a big project, but you don't intend all the little problems like, trying to get screws started and round metal poles and, shit like that. So, but no, everything's going really good. Starting to get my.
How many wounds have you had?
Yeah.
Oh yeah, try to screws it around metal poles. I don't think it's meant to do that.
I come in bleeding most every day, but yeah, starting to get some of the hemp seeds popped and ready. I'll probably be ready to plant here in a couple weeks. But just kind of starting to get excited. Things are starting to take shape a little bit, and be nice to not have to go out there every time the wind blows and reattach things, and
Oh yeah.
Everything is going really good. Starting to trim up the last run. So as we've been sitting here talking, I've been de-seeding banana OG.
What fun!
The one I pollinated is just packed with seeds. I mean,
and the one you didn't pollinate it is packed with seeds.
Not quite as bad, but yes, everything is very seeded. But yeah, this one it didn't hardly produce much bud at all. It's very, very larvae. It really got hit with that pollen. So,
yeah.
I'm just chucking seeds, and it's just gonna go into a hash bag.
You're doing this all by hand, huh?
Right now.
Yeah, I know a guy who could help you out with that.
Yeah, I know a guy too.
Yeah, I know a guy giving them away for free, buddy.
I'm sure I'm in for it here because everything is pretty well seated. So I'm gonna have some tired fingers here in a couple months. So I wouldn't doubt if you hear from me before too long, Cascadian.
Watch the it's the neck you got to worry about.
Yep. If I get that trim bin out and the footstool out, it kind of forces you back a little bit. You know what I mean? Yeah.
Yeah, it would be good to see. You need to on one of the shows, Cascadian, give us a demo of your seed shucker in action.
Yeah, let me build one I actually keep, and I will. Yeah. Every one of them I built went out the door so far, so I gotta build me one, you know.
And you've got a pile of seeds building up. Damn it! I need to
I'm
use one of
actually
these things.
getting ready to throw a cross in the tent here. Hopefully today or tomorrow. I'm, back providing. That's the goal here. I'm gonna put the blueberry blast and the so the single blueberry blast female is going in with 9 blue dream grape soda skunk crosses.
Mm-hmm.
So then the males will, hopefully there's a male in there. Fingers crossed. I've seen some females, but I haven't seen any. I've been trying to let them get root bound so the males would at least show themselves, and there's nothing in there showing themselves, which is a good and a bad thing. But hopefully there's a male in there so that I can actually make the cross. We're gonna find out here in just a couple weeks.
Yeah.
That'll be my rendition of Blue Dream with a little spin to it. So
nice,
hopefully.
nice. But no, I had an updated picture from the mystery grower of their. I can't seem to. Oh, there it is.
You guys got anything that you're growing or getting ready to pop that you're really looking forward to that's new? Raptor, anybody?
Well, I know this is from the mystery grower. This is the F1
ABCD.
generation of the K4L V2 cross Afghan landrace male. So these are the first 10. Having just shown that simulation, they're in for a rough time when I run that past them. Like, So you pop 10, yeah? All right, yeah. Let me know how that goes. And you want that outlier that's 1 in a million. Yeah. If you get it, go buy a lottery ticket. Yeah. If you get it, go buy a lottery ticket quickly. But yeah, no, by the looks of it, all looking fairly healthy there. There's another one. That one seems to have germinated way slower than the rest. But it is there from what I can see. Getting some healthy sunshine by the looks of it. Why not? While you can.
Do you
make the most of it.
Are they? Were you being informed that they're being rotated or anything? Is that how you?
No, I don't believe so. I think he just put them up on the windowsill just to let them sit in the sunshine. South facing, so southwest facing from what I gather. That it just captures as much sun as possible. I have seen pictures of it throughout the day where you can watch it go and track it around. I had fun with it when I had the chilies, the little seedlings sitting in the conservatory. You'd watch them as soon as the sun came up in the morning. They were like, whoop! They would just lock onto it and then just follow it the whole day. And then when it goes down, they're all facing that way, but then they all just bounce back up again. And as soon as they sweep round once again. Yeah.
Nice.
Yeah, I thought so. I had to look it up to make sure. That's called heliotropism, where they follow the direction of the sunlight. Some plants do it, some plants don't.
And it's down to the sun shining on that side of it slows down the growth hormone, and the growth hormone goes to the shaded side, which way around it works. It moves the growth hormone to the other side, which causes it to grow and curve over like that, ever so slightly. So it just wiggles its way. At least that's how it was explained back in the day. It might be less. Might be different by now. Science.
Well, I think I think you're right. It causes the cells on the shady side to elongate faster than the cells on the switch
Hmm.
side.
Yeah, that's why I was wondering if it got turned around and if anyone does that kind of stuff, but doesn't really seem feasible once you look into scale, like farming or farmers doing that, you know, turning every single pot, every single day, not feasible. So yeah,
But the other big
I've heard
advantage
of some people doing it.
in a field, though, outdoors, you expect the plant to be getting sun from like there to this. The plant naturally is just tracking it from there all the way over to there. I mean, twisting it around's really not going to do anything. I think maybe indoors. I think I've heard people doing that where they turn them around.
Yeah. Well, indoors, it's just, well, in most people's setup, it's just a fixed position. It's like right above it. And then they
No,
might have people that track.
I've never actually heard of anybody,
Good
but
point, Jim. If they're planted in the dirt, out there the other day with a spade, redigging.
it'd be interesting to run an indoor setup though, where you had, you know how you'll see people and they'll have trays down both sides of the room and then a hallway. And a lot of times back in the day, they'd have a light mover that went down the hallway with supplemental side lighting. It'd be interesting if you ran the light mover so that it only went from one end to the other for the whole light cycle and then it reset, and see if that affected anything, so that it took 12 hours or whatever to get to the other end. I don't think I've ever seen anybody do that.
Right, trying to replicate the actual tracking of the sun instead of going back and forth and back and forth.
I wonder if it would give him, because it's doing the whole amount, because it as soon as it comes on, it all starts to lean that way, and then okay, you do want it to be a decent length track for it to move down to take 12 hours to cover.
Right. Yeah, like
or actually maybe you don't want it to be too big,
lengthwise
otherwise
of
it's
the
going it's fucking off down that way fast.
like down the center of a greenhouse per se. A greenhouse type, a long skinny room with it down the middle. It'd be interesting just to see it. I don't know that you could elucidate any information out of it, but I don't think I've ever seen anybody do it.
I heard one. I saw something. It was one of these, again, like odd lighting sort of setups, grow ones. Have you seen the barrel one where the plants are all on the side, has the light in the middle, and the whole thing rotates over? So it goes round, the light in the middle, and it's not round horizontally. It doesn't rotate around the z-axis or y-axis, depending on how you want to look at it, and the x-axis. So it does it this way. So it actually goes upside down. The plants go upside down as it goes over the line. But I saw one that had a rotating light arm, but it rotated around in a circle at the top, and no plant will grow through it because it won't grow through the moving light. It'll stop. It won't let itself go through a moving light for whatever reason. So that's interesting. It's still going to get real close, but it's just not going to go through it.
Buddha Boy and Run Boy both kind of, what's up, boys? They both kind of ran with the idea. Down my thought, you could almost rig the system so you had a higher light intensity towards noon, and it ramped up and then faded off. And then Run Boy pointed out that you'd need a decent amount of light to do that, or you'd have periods where the end where the light mover would be too shaded to actually even produce.
It's almost like it needs to be up high enough so when it's at the far end, that end down there can still see that it's over there. But the problem is the intensity that it would need to be to have any effect on the thing down there means that anything directly under it's kind of toasted.
What if you just had the lights per normal, but you set it up so that the highest intensity went like a wave through the lights?
If you did that with LEDs, I mean, that would be a cool thing to do with LEDs. LED panels that go from 0 to 100 watts, and you just drift it up and down.
Yeah, and they automatically just ramp themselves up and ramp themselves down from one end of the room to the other. Yeah. That'd be pretty
You can
cool.
simulate different well, you the beauty about LED panels is you could just take an entire ceiling and just go the whole ceiling's LED panel, so you can light the whole thing evenly. There's no break in it. It's just whoop. But at the same time, I can move a sunrise around. I can move a color spectrum around, so I can pulse a color spectrum out across the whole room. I mean, it's like you see those really high tech. I say really high tech. I think it's maybe becoming less and less high tech these days. But the greenhouses
Modern,
have supplemental lighting, where there's light sensors on the ceiling of on the roof of the greenhouse, and as clouds go over, if its intensity dips, the lights in the greenhouse ramp up. So there's no shadow in the greenhouse. As far you look inside, and it just seems constant lighting, no matter what's happening. Bright sunlight, there you go. Off.
Yeah, it's interesting. The new technology is just letting us adapt to smaller spaces and making it more efficient. Just the fact that you can put it on a ceiling as pretty close to as flat can be, and then the same thing where, let's say, if you wanted side lighting, you don't need much to hold it. You just need a basic metal panel, and you're good. So it is all pretty feasible. And then just like you were saying before, it's just a matter of tracking, which you can have it on a rail system. Yeah. I like the idea.
I mean,
It's
it gets
very
the point
interesting.
was like, I mean, was it Mike B? I don't know. Mick 3B3. Yeah, you stick them on the walls and that, and now you go, all right, I want with full spectrum LEDs and enough of the damn things because you've got the intensity now. You've done every fucking square inch of the place. I want to be
Minus
at
the
this
floor.
latitude. This time of year, I want to simulate the lighting conditions. Boom, go, and it gives you a full day. Accelerate accelerate this season in this latitude. Because each latitude and at this altitude, so because depending on where your altitude is, your light spectrum is different. It's had less time to travel through the atmosphere. Certain things are still there, others aren't there. Oh, you're really high up, there's loads of UV in it. You're really low down, there's a lot less UV in it. Certain color spectrums are more intense at sea level than they are at 5,000 feet above sea level. So you can really dial in and the angle of the sun. I mean, it's a whole thing unto its own. I mean, you put in where you are in the world, and there is software that will tell you this is the light spectrum for where you are. And so now you could sit in Colorado and grow weed that you would only find in the northern Andes. Yeah, you won't have but you have the light spectrum for it. You may not have the other conditions for it, but you could have the light spectrum.
And then who's to know what expressions you're going to get out of that? That you wouldn't have otherwise, because it's not in that stressed environment that would it would show itself under.
Yeah. You could do all sorts of really funky things.
On tracking light.
Occasionally throw in a thunderstorm.
Right. Well, that's what I would see on the
power failure.
I believe Rapid LED has like a storm kind of system, like where you can attach. Oh man, I wish I could remember the exact product, but yeah, it's just basically replicating storms, but it's just looks more like lighting in general. So just doing something similar to what you're saying, and it was for just an aquaponic setup, just aquarium setup. You know, a lot of what LED is today is thanks to aquariums.
Yeah, no, exactly. I see Captain Terp talking about you're still missing other factors such as air pressure. Yeah, no, exactly. When we get to the point you can do that nasty, proper sealed room, and one that is really well built so that you can go, oh yeah, no, I need to drop 3 bar pressure. boom. I need to simulate
Oh,
being
we need this to be the
10,000
Himalayas.
feet up. Bearing in mind where I'm at sea level. Yeah, you don't want to be inside that room when that happens because, hey, did you hear a cracking sound?
Uh,
You become back in little
where's my
meat,
watch?
squishy meat
Oh
product
man,
in a
shattered.
box. Yeah, as the outside world crunches in around you. But yeah, it would be great. I mean, yeah, I mean, I've seen somewhere trying to do it. I'm sure it's in America. Well, I mean, it would only be in America where they're trying to do it. But where a guy,
Yeah,
they've been
America.
dealing this kind of lighting system, and where you could tweak maybe some of the air pressure. I mean, I'm being facetious by saying it's going to be built to that point. But it would be interesting to talk about how much you can. Because I don't think, yeah, I mean, like the air pressure thing is interesting, but it's remarkable just how different it is. I mean, be in Colorado, empty a plastic bottle, close the lid, fly to New York or LA or wherever, and have a look at the bottle when you take it out your bag. The whole thing's like fucking crushed. And that's what, only a mile difference. Colorado's a mile up, Denver a mile high. Yeah, it's a huge amount of pressure. So I think it does make a difference, but I think right now, when people talk about pressure and that, I just don't think right now we're in a position as a average home grower to be able to affect pressure to that degree in our home grow. Because the second we try to, your entire tent would just you'd
I
look like
mean,
you were
it's
vacuum sealed.
it is feasible, and you could make a small chamber to like examine it, and you run into the whole like, okay, make sure it's trained, it's going to grow. You have to make sure you have it big enough to work with that growth, but still at the same time small enough so you can still make it cost efficient and also like,
It
you
would
know
be
what I'm
interesting.
saying?
What would
Just
be
like
the
not
effect of
just a
every
big
time
huge
you?
room that, yeah, go ahead.
I mean, what would the effect would be like every time you open it, though? The pressure either ramps up or the pressure totally tanks, depending on what you're doing, which way you're
I think
running
you would
it.
just
So
have more control at its smaller one. That's why I mentioned
you,
it.
you've got to be able to sort of like seal it in and have it completely sealed in, so you can't go into that space, because that's the real catch. Is every time you open the door, you're
You
going
change
from
the
a mile
pressure.
up to sea level and like doing it like that, unless you want to decompress it, like spend an
Yeah,
hour
you would
decompressing.
need almost like you do on like a space
Mm.
station,
Like the
where
bends.
before you go in, you're in a separate decompression chamber, and then you go in to the actual like lab space or module.
Well, it's like decompressing. Like, you don't want to come up too fast. That's usually the problem. You're
Yeah.
coming from the high pressure to the low pressure. It'll create a problem. But again,
the
but all
bends.
good fun. I mean, I'd love to give it a whirl. I tell you what, though, we've been rambling on for about an hour now.
5 minutes past. Yeah.
I think I didn't smoke on the show today.
Wow, Lefty.
Busy hands.
The only
Lefty's
one other
nemesis.
thing I kind of wonder about the simulation that you played is, could we factor in environmental things such as a high moisture environment, making it more difficult for pollen to be able to get spread or to have a shorter lifespan? Could
Yep.
we factor in a very arid environment so that the potential for pollen to carry farther and to last longer would be much greater?
I could create zones on the background, the board on the background, divided up into zones and say, oh, this is an arid zone, this is a humid zone, this is cold, this is hot, this is optimal. But if you have these genetic traits as well, they will allow you to do better in these zones, as well as, yeah, as you say, something like I can increase the distance you travel. If you're in this zone, your ability to travel further is X. So your maximum distance just got a lot greater, but it could travel, that maximum distance could knock you clean out of that zone and into the next one, at which point it'd be a high humidity one and you could wind up in, boom, you're just, yeah. Oh yeah, absolutely.
And I suppose the
I mean,
last
it's
thought
like,
is, could that same zoning allow you to adjust altitude? So, for
Mhm.
example, it's easy for the pollen from up on high to blow down into the valley, but it's much more difficult for valley pollen to make its way up the mountain. So, could you use zoning in your modeling to represent different geographic data in that respect?
yeah, you could say that if it's, yeah, you could apply a weighting to the pollen will move further into a valley zone than it would into a mountainous zone. So if it moves into mountainous zone, it will usually only be moving into the foothills. It very rarely makes it into the middle. Would be the peak, for example. It would
Excellent.
struggle to get to the peak. Yeah, you could do that. Yeah, absolutely.
Because now we've just cracked in enough detail that someone can actually apply it to their microclimate. Someone could actually look around where they're at and actually get a decent idea how to model this for themselves using the tools you've just given them, Pete. Bravo. Way to democratize science, buddy.
Yeah, purely for making a visualization, just to have a play with it. If these plants have these favorable traits, but what you might be able to do is recognize in some of your plants, oh, they have these traits, and I always see them when this happens. Oh, okay, we'll plug that in. You get that idea about taking, the more data you accumulate, you're going, we think this is what I'm growing, these conditions, these phenotypes, but this genotype. Now, if I see this genotype, I can model how it would behave in these environments because I've got enough other data to tweak the parameters of the model that says if you're this in this environment, this is how you will behave. Because I've captured enough of that data to understand how it will do it. Whoa.
Excellent. I love it. I love it.
And
I guess anyone, if you want to keep going on this, join us in the after chat. You're welcome to jump
exactly.
in and we'll keep nerding out about this stuff.
Magma, could you potentially calculate pollen spread in a geographic area? Yeah, you could calculate pollen spread in a
That's awesome.
geographic area, but I mean, that's just understanding. That's not this. This is just, that calculation is understand air currents, the geography of the area, plug that in.
Yeah.
I would do that in a different way, but yes, you can model it. Yes.
Yeah. Look at the big brain on Pete.
I would take a local 3D model of the area and just run air currents through that and drop pollen into it.
Wind
Literally
pressure,
virtual pollen in.
how much cold and warm air comes in. Yeah.
Ooh,
Look
yes.
at climate models. Boom.
Oh yeah.
And geographic, yeah. But yeah. If we could always
That was
go
what I was
in.
going to also talk about, but I forgot to.
All right.
Sorry.
Yeah.
Was the one about
Yeah.
temperature and that, but
There
I
was a
posted
lot
a couple
of
of
info.
videos up on the
Seems like this
Operation
is going to
Grow
be a
one.
multiple episode kind of a deal. But you were saying you already had some models.
Well, I posted up on the Operation Grow show channel and on the Peel Grow one. I did a couple of just showing like the difference between LED and HPS or HID lighting, how they heat the environment differently. I've got to redo the HID one, so it's a little bit easier to see what's going on. But you see with the LED one, all the heat just goes boom straight off the top of the LEDs. With the HID one, it's like the floor warms up, the sides of the shroud warms up, so you got this heat coming from everywhere. Again, it's just one of those two. Don't forget the difference of airspeed on the leeward side of an incline with the strong tailwind. All right, well, then I tell you what.
Is that an African swallow or a European swallow?
One or two coconuts. Okay, excellent. We'll keep rabbiting away. We're going to jump into the after show. So if you want to join us there, please do. Let me actually post the link for that now. Here it is. Just add an extra character on it. No, there we go. So yeah, there's the link. Just went up in chat. Feel free to jump in and join us. But otherwise, on that note, Cascadian, where can everybody find you, sir?
Cascading Grown on Instagram, here on Saturdays, everywhere else if you're lucky.
Fantastic. Lefty, where can we find you, buddy, if not in the bowels of a greenhouse?
Probably be sitting here fucking sorting seeds for the next 6 months. No, man, you can find me on Instagram
Hey,
Lefty's Farm, and
Instagram, is that the German Instagram? Instagram.
yeah, and on Cannabis at
Ah.
Lefty's Farm, and here with Pete and the guys every Saturday on Operation Grow.
excellent, excellent. And GMF, buddy, where can we find you, sir?
Hanging out with you reprobates, usually here on Operation Grow, or over in the neighborhood, or honestly, in your dreams if you're unlucky.
Scary stuff. Perfect. All right then, Raptor.
Yeah. Good seeing you all. Great show. Lots of information. Learned a lot. Looking forward to the future progress of the project. Yeah, I'm Raptor Grow. You can find me at Raptor Grow, all one word, all lowercase if it comes out here. Yep. You could also find me here, Operation Grow, same day, same time, Pacific Standard Time, 1 p.m. And yeah, I believe you could find me at the Neighborhood Grow Show. Please check us out Mondays at 4 p.m. Pacific Standard Time, and I believe 7 Eastern. So yeah, 12 UK. If anyone's up, welcome to join.
I'm sure there will be. I'm sure we'll be able to. And you can always find me at PL Grow Systems on Instagram. Also, plgrow.systems is the website. Find us there. Mind your units for monitoring your environment, of course. Use the discount code OG Show for 10% off. Yeah. And on that note, I hope to catch everybody next week. We'll be back with some more information. Everybody stay safe. Enjoy what looks like to be good weather, and yeah, keep an eye on those environments, temperatures, etc. It's going to get a little crazy. So yeah, once again, feel free to join us in the after show.